Good morning, everybody. My name is Mike Capuccio. I want to thank everybody for coming to the Mitsubishi Clean Heat webinar this morning. I'm just going to give it about 30 seconds. I've got some more people that are actually coming in right now, so I just want to make sure that everybody is on. Give it about 15 seconds, 15, 20 seconds. Okay, I think we're going to get started. So again, good morning. My name is Mike Capuccio. I want to thank you all for coming to the webinar this morning. I'm going to start it off with my first slide with some housekeeping. Again, thank you for joining. We're going to have a live chat as we go through everything, so you can direct your questions directly to the chat. We do have two comfort consultants on the chat right now, Dave Capola and James Smithel, so they'll be answering your questions as we go through the webinar. Please feel free to ask anything at that point in time. You will be muted throughout the seminar. And I did create one poll this morning to kind of see what everybody was really looking to actually learn from the webinar. So I'm going to throw the poll up quickly and see what everyone is looking at. And what I'm getting at is a lot of people want to know how heat pumps work. How do the rebates, incentives work? So it's pretty from a percentage standpoint, it looks pretty even across the poll. So I'm going to end the poll because I don't see anything else coming into the poll right now. So that did launch when we first put that out there. So that was good. So I'm going to go to the next slide here. And get rid of that. So I'm going to move on. To the next slide. Oh, I'm sorry. So why should I consider clean heat for my home? It's definitely, I want to get into it as far as why. It's a greener, cleaner way to heat your home. If we look at how everything is moving towards everything today, picture on the left just shows coal burning, a lot of carbon going into the air. And as we see how things are moving towards greener energy is solar, windmills, and part of this is heat pumps that are going to be being installed in homes over the next 10 to 20 years. I mean, we've been doing it for 20 years right now, and it's really becoming a newer, cleaner way to heat your home, which we're going to get into in a few minutes. But if we look around the country, in the US and other countries, of how they heat their homes, most of it is being done by heat pumps. So when we look at the United States, 8% of homes are being heated by heat pumps today. So we can see how we're very, very far behind on where we're at with not technology, but using fossil fuels to heat our homes. So when we look at how energy is used in our homes today, space heating, 45% of the energy is going to space heating, and the other 18% to water heating, and 9% to the space cooling. So a lot of the other energy things are just lighting, electronics, refrigerators, etc. So this is a big part of how we use energy to heat and cool and make hot water in our homes today. So I want to look at how heat pumps were in the past and how they are in the present. Okay. So when we look at these photographs here, I'll kind of put my pointer on here. This was the past of a heat pump. You probably all know what a specific wall-mounted ductless mini split looks like. And it was a wall-mounted unit, and it was only used in basically one-to-one. What do I mean by one-to-one? It had one indoor unit and one outdoor condenser. They were only ductless only. They didn't have any ductwork. They were used for spot cooling. And they were really niche applications, sunrooms, basements, things like that, additions. It really wasn't designed for a whole home, and there was very little product awareness at the time. When we move over to the photo on the right, on the present, and we look at whole home applications now, where they're multi-zone, you can use ductwork, you can use ductless. They're more of a zone comfort solution for your home, and they're being used in whole home applications now. We've done hundreds of homes in the New England area where we've used heat pumps to heat your home. And if you look at this home, you can kind of see the big thing about this is everything is zoned out. Each room has its own temperature, it has its own unit. You can see there's 2 wall units here, another wall unit here. You can actually see a unit that sits in the ceiling here. And then there could be ductwork in this space. And this is where the outdoor condenser would sit outside. So this is the present. This was the past. Past was just one unit, one indoor, one outdoor. Now you can do multiple indoor units within your home, which we call a multi-zone system, which does give you a zoning of your home, which creates comfort in your home at that point too. It also has energy savings because it'll allow you to turn rooms off and on and set different temperatures when you're not in different rooms. Let's move on to the next slide. I want to look at how electricity is used in our homes in the United States. 50% of it is used on heating and air conditioning, and again, 11% on water heating. Kind of rolls back to that pie chart that I was showing you a little bit earlier, but you can see that electric use in the homes is a lot of it is being used with HVAC and not the most efficient ways. So let's talk about air source heat pumps and how they're greener and cleaner. Let's take a look at this and how they're actually going to work. Okay. This is a basic refrigeration cycle. What it has is it has one outdoor unit, which we call the condensing unit. The compressor sits inside of this. And inside of the home is what we call the indoor coil or the indoor unit. Refrigerant flows from the compressor to the indoor unit, which heats up this coil inside. It can either heat it or cool it for air conditioning. Then the refrigerant flows back through the outdoor coil in the condensing unit and goes back into the condenser right here. So it's basically, we're not moving air through pipes or anything like that. We're moving liquid refrigerant through 2 pipes that go to an indoor unit in your home. All right. A lot of people think that there's air or there might be things flowing through those pipes. It is either high pressure or low pressure refrigerant that's flowing through those pipes to the indoor of the home. We're going to take a look at what the compressors look like inside of these units and how efficiency is picked up. When we look at a standard air conditioning compressor, and this could even be a heat pump compressor, which I'm going to kind of refer to now, but what happens is there's one thermostat in the home. Usually it sits in the middle of a hallway somewhere, and basically it comes on, it calls, the compressor comes on. You can see right here, this is the temperature. The temperature might get colder in some rooms, warmer in some rooms, goes on, shuts off when it hits the set point of the temperature, 75 degrees. Then it sits there for a little bit, it warms up, it comes back on. As the temperature rises, it pulls back down again, and it goes on and off, and it's always running at 60 hertz from 0 to 60. This is where you kind of see the lights dim in your house sometimes, and it's when the compressor comes on. It's the highest amount of current that's drawn at that time. It's a very inefficient system, and it has a lot of hot and cold spots in the house. I'm going to show you now at what a compressor in a heat pump works like in a variable speed heat pumps. All of these heat pumps from Mitsubishi Electric that we're selling, or different brands that we are selling now, all have an inverter-driven compressor in it. What is an inverter-driven compressor? Well, it's a lot like cruise control in your car. And the previous slide, if I just flip back to this previous slide for 1 second, I want you to look at this as city driving. This is an on and off the gas pedal, where we know we don't have good gas mileage. I'm going to consider this slide here as cruise control. Now, let me get into how this works. All right. When the compressor comes on, the thermostat says, hey, my room is warm or my room is cold and I need the compressor to come on. It starts at a very, very soft speed. Starting current is very low. You can see it starts out at 0 hertz, and then the compressor ramps up to speed. As it's ramping up to speed, it's pulling down the temperature right here, either pulling it up or warming it up, depending on if you're in heating or cooling. And you can see as it reaches the temperature set point of 75 degrees at the fast speed of the compressor says, okay, I need to slow down right now because it's reaching the temperature set point. From here, you can see it starts to run at 30 hertz, not 60 hertz, okay? So as the temperature gets to the set point, the compressor speeds up and slows down as needed for the space. Keeps rotating speeds at low levels after the temperature is stabilized. It is not an on and off system. It does not turn on and turn off all day long. It basically speeds up and slows down. So let's look at a Boston heating season. A lot of people say heat pumps, don't work and they're not really designed for cold temperatures. Well, that's a myth. Those were the old days. But what I want to show you here is heating hours and temperatures, okay? Because this is where heat pumps are most efficient, between 20 and 50 degrees. They're very, very efficient at that point. When we get down into the lower temperatures, as you can see, here's the annual hours, okay? This is 1 year of a heating season. In minus 10 degrees, we really only had 10 hours. This slide was a year ago, so we had 10 hours below minus 10, 36 below 0, 342 above 10, 20 degrees, we had 604 hours. So it really doesn't, we think it gets cold, but a lot of it is wind, wind chills. And wind chill factors do not affect heat pumps. The outdoor temperature does. So when we look at these temperatures during the day when the sun is out and those long periods of time, the bulk of our heating hours are being done between 20 and 50 degrees, okay? So I'm gonna, move on with this. This is the air conditioning slides when we look at 60 and 70. So, when we even look at 90 degrees, sometimes we think, oh, we have a lot of days over 90. We have a lot of days 88, 89 that are humid, and there aren't as many. So how does this come into play? I'm going to show you. Here's heat pumps versus fossil fuel costs. And the way we look at these costs are what it costs per million BTU to operate, okay? So when we look at these slides and we look at how much it costs to run electric resistance heat to create a million BTUs, these are what it costs: $52 to create a million BTUs, oil, $27.19. This has gone up. This slide was produced at the beginning of the year, so this is definitely probably somewhere around 37, probably about the cost of propane right now. All right. And then you start to look at these ones that say COP. It has, what does COP mean? COP is what we call the coefficient of power that I'm going to get into in a minute. But the higher the COP, the more efficient the system is and how much less it will cost you to operate. Okay, and the COPs are based at different temperatures, outdoor temperatures. So the lowest COP is 2, 3, 3.5, and 4, the highest being 4. And as you can see, as the number goes up higher, the cost per BTU per million is lower. This is at the higher temperatures, okay? This is probably below 20 degrees right here. This is above 20 degrees. And you look at gas, gas is about as efficient as a heat pump, okay? So I want to kind of run through these because sometimes we think, gas and heat pumps, they're, sometimes it's more on the crossover temperatures when we get into integrated controls that I'll share with you in a little bit. We have a cost calculator slide that we're going to go over with using gas and using a heat pump and using oil. So we're going to get into that cost calculator in a little bit. But I wanted to show you the cost of fossil fuels versus heat pumps in this slide per million BTUs. That's what I was trying to get across in this slide. So next slide is what we call hyperheat. These are cold climate heat pumps, okay? The heat pumps are designed for the cold weathers. And I want to show you what a conventional heat pump does versus a cold climate heat pump. When we say capacity, 100% capacity at 47 degrees. So what does that mean? 47 degrees outside. If the heat pump is designed for 36,000 BTUs, it will give you 36,000 BTUs of heat to heat your home at those cold temperatures. Same thing with the hyperheat at 47 degrees, it'll give you 100% capacity. 23 degrees, you can see where a conventional heat pump starts to drop off in capacity. Gives you about 60% of the 36,000 BTUs that it can provide. So it's probably giving you somewhere around maybe 20,000 BTUs where it starts to not really heat your home. Where when you look at the cold climate heat pumps on the right, they're still giving you the capacity. Vice versa, 17 degrees, same thing. Get down to 5 degrees when it's cold out, these conventional heat pumps will not heat. The cold climate heat pumps will. At that point, they're still giving you the capacity. Down to minus 13 degrees, you can still get 76% capacity out of a heat pump, out of these low cold climate heat pumps that we provide from Mitsubishi Electric, okay? The myths of this, the heat pump myths are debunked. What used to happen on a regular heat pump when it wouldn't heat, there was almost like a toaster oven inside of your ductwork that would come on. It was basically just electric heat that would just glow, and a fan would run over that. And it was very, very expensive to operate. But these are no longer being used in these cold climate heat pumps. Very, very rare that backup electric heat gets put into anything to make it work, because that's where you lose all the efficiency. So how do these cold climate heat pumps work? How does we call it H2I hyperheat, how does it work? Okay, as the outdoor temperature drops outside, the compressor will then speed up because it's seeing, okay, it's cold, the house is cold, it needs heat, the compressor needs to create more speed, it creates more speed, it gets hot, it adds refrigerant to cool off the compressor, and we use that heat inside of the home at that point. So that's how it's being created, by the speed of the compressor and when it gets hot in the gas to cool it down. It's picking up the outdoor cold air, which is actually warm at that point, to use to put that inside the home. So I want to kind of go into a little bit of acronyms. A lot of people hear about acronyms with HVAC, and what do these actually mean, okay? And what does this mean when you go to purchase a heat pump or an AC system for your home, okay? We have a thing that's called SEER, S-E-E-R. The first one there. That's the seasonal energy efficiency ratio. That's the cooling output during a typical cooling season and the energy input. The thing I want you to get out of here with this is, the higher the number on the SEER rating, the better it is. So when you're looking at purchasing a heat pump or an air conditioning system for your home, the lowest SEER rating that is acceptable in the United States today is 13. Those numbers are going to be changing probably mid-season next year, as the government gets through some of these energy changes that we're going through right now. But still, the higher the number, the better, okay? The next one is EER. That's your energy efficiency ratio. You see most of these are on those big yellow stickers that you're going to see on the unit when you see them when you're purchasing them. So it's the same as SEER, but it's measured at a typical operating point, 95 degrees outdoor air temperature and 80 degrees return air on the inside of the home. Again, the EER number, the higher, the better when you start looking at that, right? Because you're going to see different numbers with different pieces of equipment. And this is usually where cost comes in. The cost is going to be less if the numbers are lower. The cost of something would be higher when these numbers are higher, because it's a more efficient piece of equipment. You have to look at the payback in that when you're purchasing something like that. The next one is HSPF. This is the heating season performance factor. This is very, very big when you start to look at these for heating, okay? Because a lot of HSPFs are different in different manufacturers and different heat pumps. Again, the higher the number, the better, okay? Please make sure that these numbers are higher, because if they're lower, it's going to cost you more to operate. The next is COP that we were talking about when we were looking at those costs, which is the coefficient of performance. All right, that's the ratio of heat supplied or removed from a system divided by the electrical energy supplied at a fixed state. All right, a little confusing, but what I want you to get out of this again is the COP, the higher the number, the better. It's the amount of heat supplied put into there of how the electrical energy is being supplied in a fixed state. So again, when you look at all these numbers, it's the higher, the better. I hope that helps some when you're looking at purchasing, because this is very, very important when you start to go look at this. So we're going to look at how some of these things actually operate with the coefficient of power. Remember when I showed you on the previous slide that heat pumps could run at 3.7 up to 4 down to 2, okay? So these are your average COPs. What you put in is what you get out. A boiler is about 0.96, direct heat 0.82, a furnace 0.98 when they say 98 efficient heat. That's what they're talking about. Here's the COP coming out of it. The resistance heat, put one in, get one out. A standard heat pump, 1.86. And this is a mini split that ramps up. The reason why this goes from 2 to 4 is because they speed up and they slow down, and you get different efficiencies when that happens. Okay, we're going to talk about, enough with learning all that. We're going to kind of get into some product right now and some common decibel levels. What I want to touch on this first is the decibel level so people can understand what I'm trying to accomplish here, okay? So common decibel levels, a lawnmower, runs at 90 dB, a blow dryer 80 dB, vacuum cleaner 75. A normal conversation is 50, a whisper is 30. 30 decibels is a human whisper. I want you to look at some of these indoor units that are provided. Here's one right here. Here's a wall mount unit. Here's a window unit on an air conditioning side. When you look at an average Frigidaire window unit, it runs at about 63 decibels. When you look at our floor mount units and our wall mount units, they have multiple different decibel levels because of the fan speed. So when you look at a human whisper at 30, that's about where our fan is on medium. On high, it's about 45. A normal conversation is 50. It's still below that. These indoor units are very, very quiet. We call them whisper quiet. You don't even know that they're on. I've actually got one running in my office right now. I don't even know it's on while it's running. So very, very quiet. So I want to look at the residential M series. What we call M series is on the Mitsubishi side is the indoor units that can actually be purchased for your home. So for those of you that don't know, I mean, this is a standard wall mount unit that it can be put in a home. This is a floor mount unit that can be put in a home. This is a ceiling recess unit that can go into a home. This goes up. You do not see this black pot. You only see this grill. This sits flush in the ceiling of a bedroom, living room, etc. Same thing here, but this is a 2 foot by 2 foot box that would need to be framed into a specific area. It's used a lot in new construction of big family rooms. This can fit into joist 16 on center. This is a small unit that you can put ductwork on in the front that would go into rooms. This is a whole home ducted unit that can be put in attics and be use ductwork or use existing ductwork from an air conditioning system that might be there now if you're looking to swap your air conditioning system to a heat pump. I'll get into that with gas heat, maybe how that might work a little bit. And this is the actual wall-mounted thermostat. This is wireless that can be operated with any one of these units. Is a wireless thermostat, or they do come with handheld controls as well. I'll get into the controls in a little bit. Just want to show you just a quick photograph of what a wall-mounted thermostat might look like. So this is a standard one-to-one heating system. And what we mean by one-to-one, we have one outdoor condensing unit and one indoor unit. That's all it uses an addition, and home office, bedroom, garage, wherever you'd want to put that, you can do, one outdoor unit with ductwork, wall mounts, however you would want to put this together. Okay. This is a standard heating system. Okay. So we have heat pumps that do not heat down to -13. They heat down to 17 degrees. All right. These are not as efficient on the low end with heating. These would probably be used to supplement gas heat or maybe just air conditioning at that point. This is a standard zone one-to-one hyperheat system, low cold climate heat pump that can be used to heat your home. Again, can be used with ductwork. Outdoor unit has Kumu Cloud on it. It does have cloud-based controls that work with the wireless thermostat. Can be used with wall mounts or ductwork. Here's our multi-zone port system, okay, that can be used with 5 indoor units. I'm going to show you there are systems that can be used with 8, and we would need a different component at that point, but you can mix and match with this 5-port system. This starts at 2. You can do 2 indoor units up to 5, depending on what you want to do. And you can see there's multiple different indoor units as far as a floor mount unit, a high wall unit, a ceiling recessed unit can be used here as well. This is a multi-zone branch box system, okay? What do I mean by that? This is 8 indoor units, and you can see, give me one second. There's multiple different indoor units with it. The big difference is it's this thing called the branch box. These either go in the attic or basement of a home. They can be put outside in an enclosure box as well, near the condensing unit. And then these pipes go from the outdoor unit to the branch box, and the branch box to all of the indoor units that would go into the home. Mix it, you can see a good mix and match here of ceiling recessed, wall mount, floor mount, and ducted units with this system. Same thing with the hyperheat unit. I just want to point out, outdoor unit, a little bit bigger than that, and everything you're going to see that is a cold climate heat pump will have a H2I symbol on it. Again, branch box related. This cold climate heat pump, hyperheat is what we call it, will run down to -13 degrees. Okay. If you have any questions on product, feel free to direct those to the chat. There are people there that can answer those questions for you. So I'm going to talk a little bit about controls. What controls those actual indoor units? All right. Basically, there's a handheld remote control that does come standard with all of them. Okay. These are the actual modes. I was actually at a Mitsubishi meeting this week where they said these actual symbols are going to be changing for the modes, and they will say heat and cool soon. So this is a cooling mode. This is a heating mode, obviously with the sun. We do display it over here. It does make it a little bit easier, but this is a basic handheld remote control. It does not have a 24-hour programmable timer. It is only 7 days. Basically, it's a 1-day timer, 24 hours that will switch from on and off. Basically, is what it will do. It can't do setback temperatures or anything like that. So it's your standard wall mount controller. It comes standard with every indoor unit. More advanced wireless remote control that comes with the higher SEER units, where you can do the programming and setting days, setting programs and everything on it 7 days a week with setbacks. This is more of an advanced control that does come with the more advanced units. The other thing is you can also use the MHK2 controller. Okay, this is a wall-mounted thermostat that goes with any one of our indoor units. Has red link. It is, you can use it with Mitsubishi's Kumu Cloud setup. It has dual set point changeover. Celsius works with wireless interfaces, but it is available with any type of indoor unit that we do make. So you don't have to use the handheld remote control. Sometimes we find people don't want them. They get lost. They don't want to use them or anything. This is actually made by Honeywell for Mitsubishi Electric. Next one is the thermostat interface. Okay, if you wanted to use anybody's thermostat, you can do that. You would need to add this little control in here to the indoor unit and a transformer, and then you can use a standard 24-volt thermostat as well. A lot of times this gets used with people's existing heating and air conditioning systems, so or our ducted unit. Also, Kumu Cloud is available, works with Alexa as well. What is Kumu Cloud? Kumu Cloud is a priority app for Mitsubishi that goes onto your phone. This little device here gets installed in the indoor units. It just plugs in, and then we program your smart device. Works with Android, works with Apple to be able to do what you need to do for web service and monitoring and things like that on your actual home. So I'm going to now touch a little bit on integrated controls. What is an integrated control? It's a control that works with your system to basically switch your heating and cooling on and off at below certain temperatures, so where it's staged. Okay, I'm going to get into that in a minute and how that actually works. But what would happen is you would put an integrated control system that would operate your heating system and your existing heating system and the heat pump, and it would switch over at different temperatures. There's multiple different ways to do this with an outdoor sensor. So basically, like when I was talking about the gas systems and how they operate, you might want to run your furnace below 30 degrees and use your heat pump above 30 degrees. These would be some of the controls that you would do that with. You can use Mitsubishi system, There's another one called IFTT, where you integrate this with an app with Honeywell thermostats. There's another one that we can use that's called FlarePuck Pro that we use, which we go in and we put a actual little pro thermostat in with each unit and into the home, and they all talk to each other. They know what the outdoor temperature is via an app, and basically it switches your boiler on and switches your boiler off, brings your heat pumps on above a certain temperature, shuts your boiler off below a certain temperature. So it works, they work in conjunction with each other for the efficiency of what we're trying to accomplish in the home by using the fossil fuels maybe at a lower temperature and using the heat pumps at a higher temperature. So let's look at some whole home energy solutions to save energy in your home. Okay, so when we look at a home, we go in, we look at a home, and we try to look at it from a zone comfort standpoint. When we come into the home, we have to look at it to how to zone out an actual home. How would a heat pump work in your home the most efficient way? So again, here's a home here with you know, seven different rooms of, you know, how it could possibly be done. And what I want you to get out of this is there's many configurations to fit your needs. All right. When we come into a home, you know, here's the basic layout of a home and how we would attempt to look at an actual home. So the next slide I'm going to bring up is actually some pictures of a home and breaking it down into zones with colors. Okay. So what I've done with this home here is I've looked at it as here's the 5 zones that I would look at in this home. Master bedroom, master bathroom, bedroom 2, bedroom 3, great room, and the kitchen and nook area here is how we would probably look at doing a home like this, okay? And this could be done with 5 indoor units, could be 5 single zone systems, which I probably wouldn't do, but what I wanted to do is just show you how 5 zones would probably work in a home so you can get an idea of how your home would possibly lay out, okay? 3-zone system and 2-zone systems is how this could be done. This could be done with, you know, these 3 zones right here could be on maybe one ducted unit or 3 wall mount units on this side of the home. And then the other side of the home could maybe be done with a condenser with 2 indoor units, maybe wall mount units. But what I want you to try and accomplish out of this is how zoning would work in your home, breaking the lines between the rooms and creating these with zones in your home, okay? I'm going to talk a little bit about the installation process, okay? This is really big when you start looking at installers that can do this in your home and, you know, what are the steps? What gets done on this? You know, there's an installation process that goes down with this. And, you know, obviously this is a big investment in your home if you're thinking about doing this in your home. And you want to get this done right the first time. You don't want to be doing this 2 and 3 times. And I'm going to show you a little bit about how it would get done, but there'd be a step 1, step 2, and all the way up to step 6. And I'm going to show you the different steps of what they are. But, you know, step 1 is, you know, setting a location, installing an indoor unit. Step 3, installing an outdoor unit. The interconnect system is the piping between the indoor and outdoor units. The leak testing, charging, and evacuating of what needs to be done. And then there's weighing in the charge and testing the system after it's completed. So I'm going to show you some photographs of just kind of, you know, what it might look like in your home when someone's doing a wall-mounted unit in your home right here, of how it would look. It would get measured on the wall. It would get centered on the wall. There is a little plate behind here, if you see it, that gets mounted to the wall. And then a little 3-inch hole will get drilled on the right-hand or left-hand side where the internet piping and drains will go to the outdoor unit. Outdoor unit gets set outside either on a wall mount bracket or a stand to keep it up out of the snow at that point. The interconnect system, you can see here, there's wiring, there's piping. You can see he's using special tools right here. This is what we call a torque wrench to get the exact tightness on these nuts that we're connecting together. There's insulation on these lines. So the interconnect system, you can see here, you can see this what we call line hide right here. And the hole right here is in the home where everything is coming out and being connected and going into this line hide system. So it's going to hide all of this stuff on the outside of the home. Step 5 is the charging and testing or pressure testing. And step 6 is actually, making sure that the unit's installed right, going through all of the tests that you need to achieve to make sure that the system is working properly. And, why is it important to use the right contractor when you're getting into this? I mean, I've done this for 40 years now, and I look at a lot of different jobs. I've seen a lot of different things across the country as we go to things. And, we've seen jobs like this that have been done where people have actually paid for jobs like this, where, it's just a matter of choosing the right contractor of what the job should look like. This is not what a heat pump in your home should look like. Again, some more slides of jobs that I've seen done that, you can see that everything this is not what you want your house to look like when it's completed. It's not what it should look like. I'm going to show you what it should look like. Condensing units sit outside. Like I told you, they sit on a stand. This is an actual stand that keeps them up out of the snow. Concrete pads. They're poured or set, precast, however. But this is how everything should look outside. Nice and neat and put together. From the outside, this is how things should look. You can see right here, there's actually a condenser sitting behind the house right here. But this is the actual line hide system coming out. This is done in an ivory line hide, white on the corners, ivory to match the outside, following the electrical lines, making it look nice and neat. You can see this home here. This is where the pipes came out of the house here. It's white next to the electrical pipe right here. You can actually see there's another white one right here that kind of came down and the condenser sat right over here in the corner of the house. So this is what a nice, neat installation should look like on the outside of your home. These are proper installation techniques. We have thousands of photographs of homes that we've done like this. So just kind of give you an idea of what things should look like. So let's look at some case studies of some homes and some significant energy savings of what was done in the home. There's a lot of things that are changing coming for 2023. So I'm going to kind of run over some of that as we start to move forward here. So I'm going to show you a home in a historical home in Easton that installed the ductless system. This was a 5-zone system. The cost to install this job was about $30,000. There was a $5,000 mass save rebate in here. And this is a partial home heating. This was a partial home heat loan. So they had done, I think, $25,000 on the partial home on the 0% for 7 years through mass save, through the heat loan that I'll get into in a minute. And the annual savings in the home, I'm going to show you, and how we accomplished this was $3,000, $3,063. And we basically got this from the ductless air source heat pump annual fuel and electric savings of right here was $3,063. Okay. What the other big thing is here on the CO2 emissions, they're now alleviating 13.4 tons of metric of carbon that is actually going out into the air. This cost calculator is available to you on Mass Save through the cost calculator to look at when you start looking at installing heat pumps in your home. What are the annual savings? Is there a payback? Okay. And when you look at this here too, this is equivalent miles of a gas vehicle. It's 31,000 miles. So there's a lot of there's savings in here, and you're helping the environment right here as well. When we get into the clean heating section of this, this is what I really want to point out. So we're going to go show you a couple more homes here. This is a Boston condo upgrade. This was electric baseboard in this home. Okay, you can see they went with wall mounts in this home right here, 1, 2. Outside of the home, this was a 3-zone system, hyper heat. Cost to install was $11,452. Mass Save rebate was $10,000. This was a whole home installation. So this was replacing existing electric heat that was in the home. So it required it basically hit the $10,000 rebate for the whole home rebate that they could get. The whole home heat loan was used, okay, for the home, and the annual savings was $2,136. Okay, where did we come up with the $2,136? Right here, we put in electric heat of what it was. It showed us our numbers. Metric tons are not as high, 2.2, because they weren't burning any fuel. So it shows you the difference here. They're just picking up electric savings on that home. I'm going to show you an Andover home. This is a hybrid heating system, okay, where this is being used to used with heating and, you know, the boiler system that's in there. So what it's doing is it's switching with integrated controls at that point. This has ceiling recessed units. You can see those ones. You can actually see now there's an example of what that would look like in a home installed into the ceiling. Wall mount units. This was a 3-zone system. It had a ducted air handler in the attic too. We don't have photographs on here, but cost to install was $24,000. Mass Save rebate was $1,000. They used the heat loan on this, and the annual savings is $25.55 per year. And we'll show you how we got this number. Okay, so the ductless, the electric annual fuel savings and electric savings at $25.55. That's the two combined together. Metric tons that they're avoiding is 11.1, which is equivalent to 26,000 miles of driving a gas vehicle. So again, when you roll back to this slide, I'm sorry, you can see the actual savings here. A lot of this is not, it's metric tons and, you know, cleaning the air up too of what we're doing here. So here is a historic home in Woburn that gets a fully upgrade. This was complete ductwork into the home. All ductwork, had all brand new ductwork installed in the home. Very, very hard job to do. Complete job with wall mounts was $75,000 to do, but this is a complete heating system in the home. It's only being heated by heat pumps. $10,000 rebate and 16.7 metric tons now of what they're actually saving. Annual fuel savings, $3,800 a year, but a huge metric number of what they're not putting into the air now, CO2 emissions, almost equivalent to $40,000 in driving an automobile. So to kind of give you an idea of how that actually all plays out and what's happening there, where, you know, this cost calculator is available to you guys on Mass Save's website. I'm going to talk a little bit about rebates for 2022 and rebates for 2023 of what's happening. Okay. I did sit in a Mass Save meeting the other day, and what they're saying right now is the rebates for 2023 are not going to change. They're going to stay the same as 2022. Let's hope that they do what they say. I truly believe they will, but I don't see any big changes coming down the pipe for that. So what does that mean? That means a mini split heat pump system, whole home system. This is if you're heating your entire home with a heat pump, is a $10,000 per home rebate. Okay, this, you have to be in the Mass Save system. You have to be on a on the program where you are paying into energy savings on your electric bill. So it's not a municipal electric. It's got to be, you know, National Grid, Eversource, things like that that are in the program. And then the partial home rebate, okay, is certain products on this website right here that you go look at, and that's $1,250 per ton up to $10,000. So you can still get a partial home rebate of up to $10,000 depending on how you're doing the home. Okay, so partial homes or whole homes, this needs to be looked at when we come into the home. So I'm going to talk a little bit about the Mass Save heat loan right now. Okay, Mass Save heat loan, from the attic to the basement, they're happy to help with everything that they're doing. They're $25,000 loans through local banks at 0% interest for 7 years to help with these programs that they're actually doing right now. Okay, so it has to be done through an energy audit. When the energy auditor comes into the home, you get a Mass Save heat loan form, you qualify for the loan, and then you have to go on and apply for the loan for what needs to get done. Some of these are also available through municipal programs. I don't know what's going to happen in 2023 with some of these municipal programs. I think most of them are going to stay, but some of them work differently. This is a Muni Helps program. and these are their rebates of what they're giving out now. Okay, and then these are the towns that this is available in. So there are still some municipal helps right now in some of these towns. A lot of this is, you have to find out town by town exactly what they're actually offering in their town. There's another company which is called Abode that I believe is staying the same for 2023. They usually follow Mass Save's rebates of how they actually fall in. So this is a different type of thing through Reading, Power, and Light, and these are the towns that are in that particular program. Okay, so you can see if you're in any ones of these towns here, these have to work through the Abode program. They do not go through the Mass Save program. These would go through them. So let's talk a little bit about the Inflation Reduction Act. I know a lot of people are apprehensive as to what, this is what we know right now. Okay, this is, I've sat in many meetings over the past few weeks of what this is all about. And there's a lot going on right now. There are going to be some changes in the next 2 years, okay? But what we know right now that is going to happen for 2023, this is where we were at right now, okay, for 2022. These were some of the tax reduction tax credits that you were getting, $300 to $600 on an electric heat pump right now. Rebate total savings might have been $1,200. In one zone, you were getting $500. So this is what we know right now for 2022. I'm going to show you what's going to happen in 2023. This is going to change January 1st. Okay, this is the 25C tax credit. Okay, this is the only change right now that we can actually say this is what's going to happen in 2023. Because a lot of the other things that have happened that I'll get into in a minute, the funds have not been released for to the states. The states haven't created any programs yet. So we're not sure how all that's going to lay out. But this is what I can tell you is definitely happening for 2023 on your tax credits, okay? Your annual tax credit for heat pump and water heat is capped at $2,000. So you can see they were at $300 to $600. Is now going to $2,000 on a tax credit, okay? Annual credit for other upgrades are capped at $1,200, which is going to reset every year as well, okay? So $600 for an electrical panel on your tax credit on your 25C, $1,200 for weatherization, $150 for home energy audits, $600 capped for other energy products, $500 for doors, okay? So making electrical panel upgrades, ear sealing, material credit, they're all eligible for these tax credits, okay? So you can get $2,000 on the tax credit, $600 for electrical panel upgrade, $2,600. You do see this will reset every year at $1,200, capped at $1,200. This is a one-time for the heat pump, all right? So these other things, if you want to do other energy upgrades to your home, those are going to reset each year, okay? Removes roofs, qualified expenditures, covers purchase of the installation, and everything has to be Energy Star rated in your homes. This is the 25C tax credit, 30% tax credits for upgrades to efficiency, $3,200 per year starting January 2023, $2,000 on the heat pumps. Now let's talk about the high efficiency electric home rebate. This is the HERA program. Okay, this is where we talk about the new Green Deal. This is the $4.5 billion in funding for a new point of sale electric home improvement rebate. And this is, all of those funds are being pushed out to low and medium income households. This is what we know as of today. Okay, I don't believe this is going to change, but they don't know how this money is actually going to flow, but there's going to be rebates up to $14,000, okay, on that install for qualifying products. They're going to be administered by the state energy and offices and tribes. There won't be any double dipping for rebate grants for the same product. They can be combined with rebates from different products. It also can be combined with the 25C and 25D, and it can be combined with other state level rebates, like your mass save rebates, okay? But the last bullet point is implementation will take up to 2 years. The states have to apply for the funding, and the funds will be available till 2031. So the $4.5 billion is being distributed to 50 states. All right, so if you start dividing that up, you're going to see how much the state of Massachusetts is going to get. It's not going to be as much as we think, and it's going to be available to these types of homes. Okay, and this is how these actual rebates that we do know of how they're going to work. This has been put out by the DOREs. Is heat pump water heaters, the maximum rebate you'll get. This is how the 14,000 was administered. Is in these household income areas, 80% to 150% of your median income, 80% of your median income. And these are different in different areas of your home. I mean, of your towns and where you live, of what that is, the median income of what that town or city is. Okay, so you're going to see some of these are only 50%, some of these are 100%, based on less than 80% of your median income in your area. So you can see that a lot of this money is going towards these types of homes for upgrades. Okay, so not to say that it's a bad thing, but this is where these funds are going to be centered in. So we have to kind of look at how this is going to roll out. Here's the $8,000 for the heat pumps right here, but you might only get 50% of it if you fall in this bracket right here. So you have to look at the median income of your actual area where you are to see if you're going to fall into these particular rebates. But again, rolling the slide back, these are not going to be available. Implementation can take up to 2 years. We're seeing this is probably going to be administered through mass save somehow, but we just don't know. None of the funds have been released. Nobody has a program yet, and no one really fully knows how these funds are going to be truly given, who is going to give them to who. So what I can tell you, though, is the tax credits are available for 2023. So I'm going to kind of end it there. I told everyone I'd keep this to 45 minutes. I'm a little bit over. I apologize. But next steps, I just want to thank everybody for attending today. There is a phone number on the right-hand side if you do want more information. We did record this as well, so you will get a recording of this on Monday. Please feel free to call to book a consultation, to schedule an installation. We'll be more than happy to help you. Go to our website, N.E.T.R.inc.com. There's several ebooks there that you can download that have plenty of information that I've written over the last few years on heating, cooling, how to choose a heat pump, how to choose a contractor. And again, the webinar recording will be sent to you on Monday. And I just want to thank everybody for attending today. We got a real good audience today, a lot of chat going on. We will leave the chat open till 11 o'clock right now, probably the next 7 to 10 minutes or so. So if anybody does have questions, please feel free to direct them to the chat.